There are only two types of developers in this world: those who know the solid principles and those who uses the solid principles.
A few minutes later.
Okay, let's start with discussing the solid principles, which are important guidelines when somebody is starting with development, especially when it is in a microservice-based environment. Solid principles are often neglected, and these are something which, when kept in mind, will help us design a better solution. The solid principles basically are a set of 5 principles that we have, namely single responsibility principle, open close principle, liskov substitution principle, interface segregation principle, and dependency inversion principle. So these are the 5 principles which makes solid principles in completion. We will discuss all 5 of these in details with examples. So without wasting any time, let's get ahead. So first one is single responsibility principle. In crux or in simplicity, it's like a class should have one and only one reason to change. That means a class should only have one responsibility. Let's take this with one example. So let's say if there is a class task and it is having 3 functions. One is download file from some location, parse the file, and save the file content to database. Now, do you think these 3 functions should be part of the same class? Do you think these are 3 different responsibilities or these are single responsibilities? In my understanding and from the design perspective, these are 3 different responsibilities and these should be part of 3 different classes which we can use. One can be a file class which does the download file, then maybe an input output class which can help us parse the file, and then there will be a database file or persisting class which can help us save this file to database. So this is how the design should be as per single responsibility principle. Moving up to next is open close principle. Open close principle is often very confusing with the name because it is open and closed, but it is very simple that entities or classes should be open for extension, but these should be kept as closed for modification. At this point of time, this might be even more confusing, but let's try to take this one as well with the example. So open close principle, let's say this is the example that we have. So there is a function called area. It takes object array of name shapes. Then there is an area which we have initialized to 0. Then we iterate over the shapes, and then the loop checks if the shape is rectangle, then shape is typecasted into type rectangle, and then area is calculated as width multiplied by height. Otherwise, what we are doing is we are assuming that this shape is circle, then we typecast the shape as circle, and then perform the area calculation as radius into radius multiplied by pi, which is the area calculation for circle. This, as the design, is not following the OCP, like open close principle. Why? Because if we have to make changes, then it will all need to happen in area class, and we cannot simply add one more shape if we want. For example, if our class right now has 2 shapes, rectangle and circle, if we need to add the third one, then this will be a problem. So in order to avoid this, what should be the better design? We should have an abstract class named shape. It should have an abstract function called area. Rectangle should inherit shape, have the property of width and height with their getter and setters, and then there will be an area calculation which should override the double area in the abstract class and return width into height. Similarly, for rectangle as well, it should take radius as parameter, and there should be a property radius, and then area should be calculated. With this, if we have to introduce a third class, then it will be very simple. All we need to do is just implement or inherit the shape interface or abstract class, whatever we have defined, and just create the next shape that we want. So this is about open close principle. The next principle that we're going to discuss is liskov substitution principle. Liskov substitution principle says that subtypes or classes which are inherited, or let's say child classes, must be substitutable for their base class. What does that mean is, let's say if there is an abstract class or a parent class or interface which has been implemented, then the subtypes which are implementing this should be able to act as a substitute for the base type. Let's consider this also with an example. For example, if we have a class bird and it has a function called fly. Now this duck is extending bird. That means it's inheriting the bird class, which means fly function will be there in duck as well. Similarly, ostrich is also extending bird, which means the fly will also be part of ostrich class. But do you think ostrich fly? No, ostrich does not fly. So in this case, subtype is not a substitute to the actual bird class. It's just for a design purpose that we have ostrich extending the bird class. In actual, it should not happen. The correct design as per Liskov substitution principle should be, we should have a class bird and another class called flying bird, which should extend bird, and then flying bird should have this void fly. So in the previous example that we have seen, what should actually happen is duck should extend flying birds and ostrich should extend birds. So this one is a solid principle which is very important, and Liskov substitute principle I think is the most important one out of all. The next solid principle is interface segregation principle. The interface segregation principle says that dependency of one class on another should be dependent on the smallest possible interface. It should not be like that if there is a class which is inheriting another interface or abstract class, then it should not be forced to implement any functionality which is not needed. This is very simple to understand, but at times what happens is, in order to reuse the code, we tend to get into a situation where we neglect the interface segregation principle. So let's take this one as well with the example. Let's say there is a class animal. It has got two functions, feed and groom, both abstract. Then there is a dog which implements animal, and it has feed and groom along with their implementations. Similarly, tiger is also implementing animal. Then there are two functions that it needs to implement, feed and groom. Feed is fine for tiger class, but groom is something which is not needed, because in case of, let's say, tiger, in general, grooming is something which is not needed because it's not a pet animal. So the correct design here should be, there should be a class animal which should have feed, then there should be a class pet which extends animal and adds a function groom. So dog should implement pet, which means it should have feed and groom both implemented. Tiger should only implement animal because it's not a pet. We do need not have a groom function, so that means void feed as the implementation. So this was interface segregation principle, which is the important solid principle. The next solid principle that we have is dependency inversion principle. So dependency inversion principle says that we should depend upon abstraction, that is interfaces, but not on concrete classes for any sort of dependency. This is often, understood the other way. Let's try to understand this also with the example. So let's say if I have an enum of type output device with two values, printer and disk, and there is a copy function that I have defined. So it takes output device as the incoming parameter. There is a integer c which I have taken as part of this function, and then we are reading it through a while loop until the read keyboard returns an end of file. Now what we are doing here is, if the device was printer, then we invoke the write printer function, otherwise we are invoking write disk function. This is not the right design which is there based on dependency injection, because let's say if I have another device which needs to be added, or if there is any sort of operation that changes, then this copy function itself becomes very clumsy, and we need to ensure that this function is also modified accordingly. Instead, the better design should be something like, we should have a reader, and then copy function should depend on these interfaces, reader and writer, and it should be stateless. So what it should do is read from the reader and write to the writer. So whosoever is implementing these readers and writers can be provided as parameters to copy function on runtime. So this is dependency inversion principle. So I hope the 5 solid principles are clear to you now. In case if you found this video useful, do not forget to subscribe to the channel so that you get updated to the next videos. Thanks for watching, and say design strong.
खत्म, बाय बाय, टाटा, गुड बाय, गया।